What about a volume change? Well, a volume change will affect the equilibrium if there are gases present, because changing the volume of a gas affects the pressure of a gas, right? So let's think this through. If we change the volume of a gas, if we decrease the volume, so we've got a container of gas and we decrease the volume, we squish the gas together, what does that do to the pressure? Pressure goes up, right? If we increase the volume, if we make the container larger, what does that do to the pressure of the gas? It goes down. So then let's think about the ideal gas equation. N is number of moles of gas. If we decrease the number of moles of gas, how would that affect the pressure if the volume and the temperature were the same? So think about maybe a mason jar that's got a gas in it. If you decrease the moles of gas, you're pulling moles out, you're taking gas out. What does that do to the pressure? It decreases it, right? And if you put more gas in, if you increase the number of moles of gas, what does that do to the pressure with volume and temperature the same? It increases it, okay? So a system involving a gas, when you change the volume, it affects the pressure. The pressure change can be compensated for by changing the number of moles of gas. So let's look at this picture. Here we've got nitrogen reacting with 3 hydrogens to form 2 ammonias. So in our reactants, we have 4 moles of gas particles. In the product, we only have 2 moles of gas particles. Remember, with gases, what the particles are don't matter. What the particles are doesn't matter. It's just the number of particles, right? And the number of particles affects the pressure, the volume, the temperature of the gas. So what we're doing here is we're going to decrease the volume. We're going to push the piston down, make this smaller. What does that do to the pressure inside? Increases the pressure. Equilibrium wants to fight against that. Oh, you increase the pressure on me? Well, I'll show you. I'll react to decrease the pressure. If it shifts to the right, it goes from 4 moles of gas to 2 moles of gas. That's going to alleviate that pressure increase, right? By shifting to the right, it can cause there to be fewer molecules of gas present, and the pressure will come down. If it shifted to the left, it would increase the number of moles of gas, and the pressure would go up more. It doesn't want to do that. Do you have any questions about that idea?
This happens because the space is smaller, so your velocity increases and your overcoming the energy barrier and stuff like that.
No, I think you're overthinking it. So we compress the gas, we change the volume, which causes the pressure to increase. An increase in pressure, you can also think of that as an increase in concentration, right? They're closer together, so the concentration's higher. But it's increasing the concentration of all of them, right? So that's a little hard to think about. Well, what would that do if they're all increasing in concentration? But the thing about this particular reaction here is the number of moles of gas reactants and the number of moles of gas products are different. It's not always true. Sometimes they're the same. But when they're different, if the reaction shifts to the right, it combines 4 particles into 2 particles. So the farther to the right it goes, the lower the pressure gets. And if it went to the left, the pressure would increase. And so the equilibrium can compensate for this increased pressure by shifting to the right to alleviate the pressure. And we actually don't need to think of it in any more complicated terms than that. There are, of course, lots of other factors and things, but we're just going to stay on the surface. Any other questions? What if we increase the volume? We pull this plunger up. We increase the volume. What does that do to the pressure? Makes it go down. What does the equilibrium want to do? It wants to put the pressure back up where it was, right? The equilibrium fights against change. If I increase the volume, that causes a decrease in pressure because that's how gases work. The equilibrium looks at this and says, oh, you decreased the pressure. I need to do something. We can't have this. We need to increase the pressure again. So now the reaction will shift to the left because that will increase the number of moles of gas. If you have more moles of gas, the pressure goes up. So you can actually push the reaction around literally by moving a piston up and down. So for volume changes, a decrease in volume will cause the reaction to shift in the direction that has fewer moles of gas particles. Now, moles of solid or liquid particles doesn't matter at all. It's just the gas particles. If we increase the volume, that would cause the pressure to go down. It'll shift to the side that has more gas particles. If you have equal numbers of gas particles on each side, moles of gas on each side is the same, changing the volume has no effect on the equilibrium. Because changing the volume affects the concentrations, but it affects the concentrations of all of the substances. And so that in itself doesn't shift the reaction. Let's look at this one. Example. Chemical equilibrium, 2SO2 plus O2 in equilibrium with 2SO3. What's the effect of decreasing the volume? Well, decreasing volume does what to the pressure? Increases the pressure. So what does the equilibrium want to do? Does it want to increase the pressure or decrease the pressure? We decrease the volume, which increased the pressure. The equilibrium wants to oppose us and cause the pressure to go back down. So this side has 3 moles of gas. This side has 2 moles of gas. If it goes to the right, if it shifts to the right, it can reduce the pressure. Does that make sense? What if we increase the volume? Increase the volume, what does that do to the pressure? Decreases the pressure. So the equilibrium opposes that and says, oh, I'm going to shift to increase the pressure. So it'll shift to the left because this has 3 moles of gas and this only has 2. I really encourage you, I'm using some gestures up here, I really encourage you to try to picture this in your mind. Picture a cylinder or a balloon or some sort of container. Okay, if I'm increasing the volume, that makes the pressure go down. Okay, so it's trying to undo that pressure. I need to do what will make the pressure go up. I actually think that through every time I look at a question like this. Because I'm not good at just memorizing random relationships. That doesn't work for me. I have to picture it and be able to think about it. The other advantage of that is that you tend to remember it much longer. And that's a good thing.